There are actually quite a few formulas in section 5, but we are only going to work with 2 sets of formulas. Okay? I'll show you one set today and one set on Monday. And here again, these are not any that you're going to have to memorize. They will be given to you on your test. So actually about this much of the bottom of each page of your test is a chunk of formulas. Okay? So these are the double angle formulas. So I'm just going to give you a little bit of time to write those down. Cosine has 3 different formulas, basically because they can be rewritten using the Pythagorean identity. You don't have to memorize any of these. You just need to know how to apply them. So go ahead and write them down. They're all used. We don't have to change any angles. So what's happening with these formulas is we have a double angle, and when we apply the formula, the angle cuts down by half. So just because you see these with 2's doesn't mean that they can't be applied to other angles. For example, if you were to have like the sine of 4x, you could break that up into, that's always going to be a 2. But then when you apply the formula, when we start with 2u, when we apply the formula, it goes down to u. Here, if we start with 4x, then we would cut in half to where now our angle is 2x. You see what I mean by that? Okay. Most of the time, you're going to see a 2x or a 2 theta, but we can apply the formulas with really any even number and cut it in half when we apply the formula. Okay? So there's 2 types of problems you're going to see today. You are going to see some more solving equations, and you're going to see some simplifying problems. Okay? So we're going to do 3 examples. 1 solving, and then 2 simplifying. Okay? So here is our solving equation problem. What do you notice about this problem that could create an issue? There's a couple things that I noticed. Okay, there's a coefficient in the sign, which isn't always a problem, but it's not here, is it? Okay, so notice how our angles are different. We've never had that before, okay? We've had an angle of like 2x, and that's fine. But now we have two different angles and two different trig functions, correct? So what we can do is we can apply our double angle formula to this guy so that we have the same angle throughout our entire problem, okay? It is almost impossible to do this with different angles inside of our trig functions. Okay, so instead of sine of 2x, using your formula, we know, here I'll even show it to you, I think I have it down here. Nope, no I don't. We know that the sine of 2x is the same as 2 sine x cosine x. Okay, well what did that do for us? Now we have all of the same angle, and now we have a GCF, don't we? Both terms have what in common? Anything else? I'd say they have a 2 in common also, right? So left over here would be 1 plus 2 sine x. Factor out of 2 cosine x, left over here is 1, left over here is 2 sine x. Yes?
So even though there's like a 2 in front of the sine x, or sine 2x, you have to add another 2 in front of it.
Right, so if I highlight just this, we use the formula to get to here, but there's still that 2 coefficient that we have to multiply through. Does that answer your question? Okay. So now, we've done something like this before, right? We can set each of these equal to 0. Here, this just means the cosine is 0. Where does that happen? Pi over 2 and 3 pi over 2. And you know what? I'm going to take this back real quick. I think in your book problems, they ask you for just the solutions between 0 and 2 pi. So we'll practice that in this problem. Okay? All right, here. Are you okay with me just going straight to the sine of x equals negative 1/2? We subtract the 1. We divide over the 2. And where does the sine of x equal negative 1/2? What?
Oh my gosh, 6.
Okay. I was like, that's new. 11 pi over 6 and 7 pi over 6. Huh? I worried me there, Dallas.
I'm just going to start adding stuff.
Okay, so if you see a double angle, look for an opportunity to make a substitution with a formula. Now, if it's tangent or sine, it's pretty straightforward. However, with cosine, you're going to have to choose which one helps you the most. Okay, so look at what else is in your equation and which of the three is going to help you the most. If there's a sine in your equation and you're using the double angle for cosine, I would choose the third option. If there's a cosine, I would use the second problem, or the second option. Okay, choose whichever one helps you the most. Okay, all right, go ahead and write this one down for me. And then I want you to look at your formulas. Does this emulate any of the formulas you wrote down? Not verbatim, does it? But could we do something to make it look like one of those formulas? Braden, you're shaking your head. What could we do? Okay. Since it's not an equation, I'm going to go ahead and factor out a 2 instead of divide by 2. Okay. Oops. Out of everything, Mrs. Horner. Okay, and now, what does this look like? That looks like the cosine formula. So we can write this that I just squiggled as cosine of 2x, since we started out with x. We'll go backwards with our formula. And then we factored out that 2 that we would want to keep as a coefficient. Addison, do you have a question? No. Okay. Okay. Basically, I'm giving you the right side of the equation that we're working backwards from, but it's not going to be verbatim. We're going to have to finagle it a little bit. Okay? Would you like to do another one? You don't really have a choice. I'll let you think that you do. Last example, and then we're done with our Friday math day. Okay, does this somewhat resemble one of your formulas? Okay, which one? We know that the sine of 2u equals 2 sine u cosine u, right? Okay, well, first of all, there's this 4 out here, so I'm going to go ahead and write it like this because I need a 2 in front. Right? We need that 2 in front. Okay? Now, remember I said it didn't have to be 2u to u. Okay? We can really do this with any even number. So if I am working backwards, what angle would we have inside of our double angle formula?
Wait, I have a question. Are you supposed to take the 2 out of every 4 in that?
No, because the 4 is stuck with the angle, so we can't take it out. It stays there. Okay, that's a good question. Thank you for asking it. Okay. Now, if we apply our formula and have 4x, what would the double angle be? 8. Are you okay with that? Dad? Are you okay with that? Yeah? Okay. Tired? Okay. Yes.
Does that only go for what's in the parentheses, or is it for would it be the solution to everything?
So, like, what's in the parentheses translates to here because of that
So
formula.
that factored out 2 is don't worry about it.
Well, the factor out 2 is right here.
Oh,
Like, that came here. Does that make sense? Okay. I think you have like 4 or 5 problems for homework. Callie, can you? Really?
Yeah.
You know, like 4 or 5. But how long did it take us to do those 3 problems? 10 minutes. Okay. Have a good weekend. Make good choices. Yes.
Where did you get? What'd you do with the cosine? Like the cosine for us?